Why aren't there PCIe RAM expansions? Perhaps I may be overlooking some aspect that is an important cause as to why these don't exist, but I feel that having RAM expansions through PCIe would be perfectly feasible. I know that a lot of operating systems use virtual memory and store some lower priority items on hard disks, but considering the lower speeds, I feel that we could use some bonus not quite as fast memory. Sure, 8GB/s isn't as fast as actual RAM, but it's 10x the speed of SATA. Why not have a PCIe board with a couple of RAM slots for use with the old RAM that you just replaced with that recent upgrade? PCIe has the benefit of being on almost every motherboard out there. One adapted PCIe RAM expansion board would be, supposedly, compatible most pieces. What am I missing since this hasn't been done yet?
This is a complex issue that is highly dependent on exactly what you want to do with that RAM. In most cases, it is cheaper and better to simply replace the motherboard with a new motherboard that supports the amount of RAM that you require. I have a motherboard here in front of me that can take 16 memory modules. The largest module available is 32 GB. That's a total of 512 GB in a single machine. Never mind that 16 modules of that size would cost about $14,000, or that the Mobo also has dual 8-core CPUs on it. Having the RAM on the Mobo means that it is the highest speed possible. You can use it for both a RAM disk as well as normal program and data storage. The best of both worlds. But in your question you keep comparing it to SATA storage, so I am thinking that you'd want to use this extra RAM as a RAM disk and not for general CPU RAM. This is a valid use, and years ago people did have PCIe cards with lots of RAM on it specifically for this purpose. Those cards looked like another disk drive, and not just more CPU RAM. Often these cards had an external power connector on them so you could give them some sort of backup power in case the main power failed. These types of cards have largely gone away. They were obsoleted mainly by three things. 1. Motherboards now can have much more RAM on them than in the past. 2. There are more modern solid-state drives using flash memory and PCIe, some with large RAM caches, that work better. And 3. They were just too expensive for what limited advantages it gave. There are other reasons why you might want to have a PCIe card with lots of RAM, but all of them are applications where the card is doing something other than just storing data. Like video cards, or data acquisition cards. These things do not apply here.
This has been done. Many years ago you could buy ESA cards, pre-PCIe, with RAM on, which presented to your PC as either extended or expanded memory. This was a way to get past the 1 MB limit of the original PC. Modern PCs have a section of extra RAM attached to the video card, separate from main memory. The reason why you don't get RAM expansion cards nowadays is that latency is a serious problem. There isn't really any provision in the OS for preferred versus non-preferred RAM, so you'd have to use it as a swap disk, page file.
Update for 2021. This technology is arriving with the evolution of PCIe and DRAM, although we need to wait for the coming generations of both. The AnandTech article using a PCIe slot to install DRAM, new Samsung CXL.mem expansion module describes just this kind of technology being developed by Samsung. Samsung's unveiling today is of a CXL attached module packed to the max with DDR5. It uses a full PCIe 5.0x16 link, allowing for a theoretical bidirectional 32 GT/S, but with multiple TB of memory behind a buffer controller. In much the same way that companies like Samsung pack NAND into a U.2 sized form factor, with sufficient cooling, Samsung does the same here but with DRAM. I'm a bit skeptical about the technology labels used here. Especially PCIe 5.0, which might actually mean PCIe 4.0. As it sounds identical, and I don't think that Samsung will announce today hardware that will only be usable several years from now and for a standard that doesn't yet exist. The article notes that a DRAM slot is usually rated maximum for 18 watts. This means that a 2 TB add-in CXL module like this might need around 70 to 80 W, which would likely require active cooling and a big heatsink. This kind of hardware is evidently destined for special purpose computing, not for ordinary desktop usage.
Some minimal support for that already existed in PCIe. There is a class code /subcode 0x500, which reads memory controller, and it is actually used for some internal devices for slow inter-device communication. As far as I know, the problem here is that cache coherency is not supported for PCIe/PCIe devices in CPUs, and not required by PCIe standard. Without working cache for the memory range corresponding to PCIe device, you can say goodbye to high speed. Instead of going to cache, CPU would need to always go into PCIe device for any access to any given address. This problem was solved for CXL in CXL supporting CPUs and devices.
Ili macht Ausschnitt, Classe, Consider Subscribing.